And here we are. Hi, people. Hi, anybody who catches this. I'm Tom from the Lift and Shift Foundation, and I have Dave here with me. You can't see him right now, but you will in just a second. We're ready to start Battle of the Bots Online, and I'm going to stare at that camera instead of my screen for just a minute and explain a couple things. We have this nonprofit, the Lift and Shift Foundation, and we really like to lure veterans into science and technology. It's a place where veterans should be and belong, and not everybody feels that way. So it's part of our role to help make sure that everybody understands. It's not hard. It's not complicated. It's not anything challenging. It's actually kind of a lot of fun. And what we're going to do today is part of the fun. And you can see in the corner here, it is. Dun dun dun! Oh my gosh! How did I do that? That is hysterical. But yeah. So we're gonna show how easy this is and how fun it is, and we're gonna have our own little Battle of the Bots today online. This is a program that started back in 2018, 2019, into 2019 as an in-person event in New York City, and we would bring the robots out and invite veterans to come out with their families for the day, have some lunch, learn a little bit about coding without learning any code, learn a little bit about the robots without needing to take it apart or do anything fancy with it, and end the day with a big challenge like escaping a maze or having a sumo battle just like today, or navigating a checkerboard, or any of those other things that we can come up with. So we moved it online because of the pandemic and because this crazy virus trying to kill everyone, and here we are. It's 2022. Diseases and illnesses are still out there, and we're ready to rock and roll online. So you can probably see in the top corner here, over here somewhere, that there's a couple robots. They're set up in the corner over there. I'm actually going to go get them. I'm going to bring them over. I'm going to show a little chat. So through the day, I'll be walking back and forth, coming over here and taking our robots off and on the sumo mat and bringing them back to my workstation over here, where I may need to make some updates, do some things, make some updates, edit code, all of that kind of stuff. But this is the Make Block Ranger tank, and we have it branded today. If you've ever seen NASCAR, that's kind of funny, but this is branded today by 3D Fuel, which is a veteran-owned company that we go to for our 3D printing workshops and things. And of course, the Lift and Shift Foundation branded up. Oh, and I left a little sticker on here from last time. So these Ranger tanks are really kind of cool. They have a few features that make them fun to play with. They've got these little eyes. They're not really eyes. What they do is they transmit some signals like a bat, and they let you tell how far things are away from you. And we are going to use that today as part of our sumo battle. There isn't much coding involved in using these sensors like that, but we've taken all the challenge out of it by structuring some code that I will share in a few minutes. And now my anxiety and OCD are forcing me to peel this piece of tape off. Arrgh! Cool, because right under the tape was this second sensor right here. This is a line sensor. It actually detects shifts in color by using a infrared light source and infrared light detector. So there's some fancy science, some physics and stuff. But long story short, when light reflects off of things, that's how you see color in your eyes, by the sunlight that hits a surface and reflects off. Some of it reflects and some of it doesn't. That's what actually makes color. And this sensor right here can detect when a space the space under it turns from black to white. So these are like old technologies that you may not realize it are right now, but they're actually in use in plenty of businesses, and even in the military. Sometimes it was IBM and Honda a very long time ago had black tracks around their facilities, and you would see, the mail robots going through the facility by following these lines everywhere. That's simple technology, and once again today, it's not very complicated to code these. To code this, we're not actually coding anything. We're kind of like snapping some blocks around and making this happen. And these two robots here today are gonna duke it out, and we're gonna go through a couple rounds of sumo battle. Dave and I. Dave's gonna be driving the 3D fuel robot, and I will drive the lift and shift robot today. Yes, and without any more explanation, I'm gonna ditch myself as the screen here, and Dave can. Hi, Dave. You can chime in. But it's set up for sound, so it will.
Helps if I turn the microphone back on.
Oh, there we go. Cool. So that is Dave, an Army veteran. He's hundreds of miles, nowhere near me. We're doing this online, and we're here to battle it out over the internet. So anybody can join us. With your family, any veterans free to join these programs with your family. Grab any battle buddy anywhere. Sign up. Get into this. What I'm going to do now is switch my screens, my views. We got a couple scenes set up here, and I'm going to go to the blocks and show just some quick blocks. We have rules for the sumo battle, and we set up the rules in our code. And I know this sounds a little crazy, but I'm going to show you an example right now by opening a file from my computer, and you can't see it right now, but I'm going to open up this file called Sumo Rules. There we go. So this right here is our rules for the day, which is convenient because this means that we actually have the code built to facilitate the rules for us. So our rules for the day are the Ranger tank has to stay on the line. So you'll see a bunch of these blocks like this that say line following sensor detects something being black, and those are the rules basically. So what we've done is, as long as the line sensor is black, shows it's black, it will keep doing all of this code, and when it goes off the line, it's going to flash these lights and play a little beep, and then it's going to stop. And that's basically the rule for the day. Is our robots are allowed to put the judo moves on people or each other and get into a real sumo battle, and the loser has to stop and flash their lights to indicate that they've come off the line. And it's not really the honor system because it's put into the code here. So I'll be reviewing the code, and what I've done behind the scenes is Dave and I have been chatting already for like the last half hour or so. So Dave is actually part of our design team, and earlier this week helped me develop this code. So Dave and I have shared this in our Zoom chat already. So Dave is hundreds of miles from me with this same window open in his end, and what he's doing right now, since I've already shared this with him, is all these little blocks right here, where it says your code here, this is where you can add your judo moves, where you can put the shake and bake on your opponent. And you would do that very easily with some of these action buttons in here, like moving forward, moving right or left, all of these other things to kind of push your opponent off the line. And you would easily just throw away the red block, just like this, and add your moves. Poof. There we go, and that would be the first move. And you get options in this where you are fully on the black line or you're partially off the black line. You can set up different moves. So these are the rules, and this is how it's going to work for us today. We're going to go through a few rounds. We're going to do a best 2 out of 3. And then we'll take a break. I'll talk through some of this, and I'll let Dave adjust his code based on what he sees in the match. And while he's doing that, I'm gonna pick through some of the other code and things, and we'll do a few rounds of that until about 2 p.m. And that's when we kind of schedule for time to expire. If we get through too many rounds, we'll cut it short. But with just Dave and I here, we would probably get plenty of time to have lots of fun and watch some crazy stuff happen. And when we get back to the robots, I've got a bigger screen here where you can see up close the actual moves happening. So what I'm going to do now is I'm actually going to turn on some of the robots because I have my code for the Lift and Shift Foundation right here. So when I upload the code, I will show you. In fact, I will come back to this screen here and I will open my code right here. I'm opening my set of code. So this is the code I've defined today as my moves. My moves are down there in the bottom, and I'm not going to give Dave any hints yet, but he'll see it on his own. So I'm going to connect my Ranger robot right now. You can see my Ranger tank already has a code in it. It's already going. So I'm going to connect my Ranger tank, and you might hear windows popping up. So now that it's connected, I'm going to bring him back to this screen, and I'm going to show you what happens on my end. On my end, I'm going to connect the robots down here with this button, this connect button, and I get an option here to COM6, and I'm going to connect to the robot. Now I'm connected, and I'm going to upload my set of code right here to this robot. I'm going to click upload, and you can see some things here happening, and that's it. It's starting the upload. There's a bit of flashing on my end from my screen right here. And now I've got something else going on. So I have my hand blocking the robot. But I've successfully coded this mbot with my code. What's going to happen next is Dave's going to share his code in our Zoom window, and I'm going to do the same exact thing. I'm just going to upload Dave's code to the other robot, and then we're going to be ready for a battle. And it's so simple. The same way I opened this file from computer, Dave can save to his computer and drag and drop it right in our Zoom chat. Makes it very easy. So I'm gonna set up our Ranger tank. You can see me show up over here. Set him down. So the lift and shift tank is ready to go. And I'm not gonna pressure Dave. Dave's had maybe 20 minutes to get his code going. So in the meantime, what I'm going to do is explain a little bit more about the steps in the code and the rules and instructions, basically, for our robot today. And what I can do is I can zoom in on some of the steps here and get a little explanation that this isn't real code. The code is actually pulled over here to the side. You can see all the code. This looks complicated and scary, right? But it's not. It's a bunch of commands, and these commands mean certain things. Just like every command we used in the Army, Dave and I both being Army veterans, those commands that you saw, whether it was that list of words, or whether it's those Lego blocks that were kind of snapping together, those Lego-looking things. They're commands, and they're just like any other command. And a lot of times what I like to explain to people is that whether you're coding a robot on the screen or whether you're coding a virtual robot in a video game, they are no different than a soldier standing on a parade field. And if you've ever served in the Army or heard stories or watched movies about people issuing commands in the military, it's these are drill and ceremonies. They're kind of like formal commands you would make with a unit. And I equate these robots especially to a soldier being on a field and listening for commands. So a lot of these blocks are just simple commands, just like any soldier, sailor, airman, marine learns in basic training, and they're simple. It's things like salute. It's things like left face, right face, forward march. Well, we're looking at these blocks right now, and if I switch my view back here, you can see I can zoom into this block right here. Here's a forward march. Here's a forward march block right here. It's I don't know, half step march, because he's going 50% speed. It's that easy. It's that simple to find these blocks. And if you watch us do this live, real time, sometimes in some of the workshops you'll see me struggle. Not so much for understanding the code, but because they're hard to find. The blocks are hard to find in this panel on the side. They're organized by whether they're an action or something you would see, or something you would sense, or an event that might happen, like a key press right here, like pressing the space bar. And there are also operators, like doing some math, like comparing things, whether a line sensor is on or off, or if 5 is bigger than 3, do this. And those are questions that you can ask or tell the robot. So in here there's like a weight. There's a you can repeat a list of things. There's all kinds of stuff you can tell your robot to do, just like left face, right face, forward march. And my as I come back and chat with me for a minute, and Dave, chime in whenever you're good with your code. I'm cool with it. But the idea here is that these aren't complicated. These aren't hard commands. They're not challenging to do here, and it's not meant to be stressful in any way. It's actually kind of fun to be able to snap your code together, and we've provided this big structure so that you don't need to stress over the background code. If you want to learn more about this, we have some other workshops. Like I mentioned, Dave and I were together Thursday developing this, and I think next week we'll host another Zoom workshop on our website. Links are on our website, but we're hosting another Zoom workshop so that we can follow up and learn more about what happened, what didn't work, what did work. Talk about what we want to do, what next, what other options we could add into this part right here, how we could make our code go a little better. If somebody like Dave wanted to learn more about which moves did which parts right here, we could disassemble this code and say, well, your code didn't work right here, or you lost to the other robot because the other robot was doing this, and that's where we can kind of teach a little bit more if anybody's interested in it. But this Battle of the Bots on Twitch, on YouTube, on streaming things is really meant to be fun and kind of showcase what you can and can't do, and show everybody else how easy this is, because it's not complicated at all. It's just dragging some blocks around, and behind the scenes I have the robots all set up over here. I have all the hardware going. That takes all of the troubleshooting away from the hardware that I've encountered by hosting these events live for the last few years. Some of the challenges getting the robots connected. Some of the challenges is opening the browsers and getting the blocks to talk to the robot. You will see later in a bit, sometimes the robots have malfunctions where parts fall off, because it is this one especially is a sumo battle, and the robots can be challenging physically also. So not having me around as an engineer means you're on your own to solve those things. But having all of it here means you have an engineer to tell you quickly when things go wrong, and it kind of takes all the nerdiness out of your hands, so you can join us and have some fun. but digging in my hand for a minute. Because I'm a boy and I'm not always the smartest, and my mom used to tell me not to stop digging with that, but I'm not the best listener.
I've already sent you my code, so
Sweet!
whenever you're ready, it's in the chat.
Yes, dude. I am going to our chat right now. Ding, 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 ding. I will trust files from this sender. Yes, I will. And now I have opened Dave's files. So what you didn't see in the background is Dave and I are on a Zoom chat, and we are sharing our files back and forth right there in the Zoom chat. So he's just sent me his code. What I'm going to do is I'm going to open his code the same way I opened my code. And here we go. I'm looking for Dave. So this is Dave's set of code right here. Dave's coded this just in the last few minutes. He's added his blocks in there, and it looks just the same as it should. There's the lights and things.
You're
All
not
the
showing that.
do what? Oh,
You aren't showing it.
snap! Why is my keyboard?
There you go. Now you're showing it.
Am I?
Yeah. There's a delay between the two.
Ah, okay. I see it now. I got you.
Because I am watching Twitch. just so that I
Super.
can see it.
Yes. Cool. I'm looking at the wrong screen. I'm looking at the streaming screen, not the browser at the second. So here's Dave's code. Dave threw this code together in the last 20 minutes. He's got all the parts that we need for the rules. There's some lights that flash. There's some line sensor things that happen. I'm going to connect Dave's robot. Remember, Dave is running the 3D Fuel robot today. So I'm going to connect Dave's robot right now. And here we are, Dave's robot. Easy USB plug. Light up. One thing I've always found is these robots need to be turned on, not just connected. There's a power thing, and it's boring. It's nerd stuff. But going back to the code here, I'm going to connect to Dave's robot here on COM6. There we go. And we're connected. I'm going to upload Dave's code. And what I'm going to do is I'm going to show you this end so you can see the fun flashy lights and things. As I mash the button upload, this time you see there's some communication going on. The little communication light turns on, and there we go. So now Dave's robot is ready to go. Dave's robot has the code. So I'm going to unplug Dave's robot from the computer. I'm going to turn them off. I'm going to head over, and we're ready. We're ready to do this. They are on the lines. I'm getting ready to turn them on. They have a 2-second pause. So we're going to do best 2 out of 3 right now. And here we go. Go, go, go. Oh, they're locked. They seem to be locked. And they're not, oh, nope, not quite locked in a dead stall. But they're definitely struggling with some physics there. We'll call it in a second, but I see tread still turning here on this end. So I think the 3D Fuel robot might be is the most active in this position, but they definitely look locked right here on the tread.
Yeah, that's what I'm seeing. They look locked.
We're gonna give them a second because the 3D Fuel robot is definitely still fighting it out. And I think I'm going to give it to the 3D Fuel robot because it looks like the lift and shift robot's completely stalled. Okay, we'll count down from 5. 5, 4, 3, 2, 1. Beep. No knockout, just a technical win. Okay. So that was round 1, or yeah, match 1 of round 1. Are we ready? We're gonna do this again. Round match 2, I think. I'm terrible with all of those designations, but let's go. Let's get it on. Go. There. Oh, that one is definitely stuck. The line sensor, they went straight at each other, no veering right or left. The line sensor is caught right here on this. And I find this interesting. I'm gonna make some comments later, because I'm now seeing things that we can add in the code for moves. But I'm not gonna comment on it yet. We're gonna give it a countdown of 5. 5, 4, 3, 2, 1. We're gonna call that one a straight draw. It looked like they both kind of stopped and stalled right there. We're gonna come back, and I'm gonna set them catty corner on the lines, because today our lines are fairly wide. They're about 3 to 4 inches, 3.5 inches wide. So this black line right here is where they can't leave, and we made it wide so that they can go. And here we go. Ready? Go. Oh, I see them turning. I see them veering. Oh, they came right back onto the line, and they're caught on the wheel again, or the eye sensor again. Much less drama from the last few of these. They're absolutely stuck. And no, we'll give him to another count of 5. 5, 4, 3, 2, 1. It looks like a straight draw again. Nobody's moving, and what I'm gonna show here on the screen is these robots have this sensor sticking up here, and they are locking here on the eyes, and there is not enough side-to-side play for these robots to push each other off of them, away from the eyes. They're locking on this eye, and they're pausing, they're holding. There's not enough strength in the wheels to do any more to get them off of there. So that's interesting, and I think that's best 2 out of 3. We're going to give it to the 3D Fuel robot. So Dave's the champ so far. And what I'm going to do is I'm going to come back. I'm going to bring both robots back. I'm going to give Dave the opportunity to change his code and update his code based on what we've just seen here.
Yeah, we're working on that right now.
Dude, that is awesome. That is very, very cool. I'm happy for that. So I'm not going to change the lift and shift robots code, but hopefully the upfront view right there from the screen will give you some hints and some ideas. I have a few ideas on my own, but while you're doing that, I'm going to talk through what the actual code does that gets us into the sumo battle, because it's kind of lengthy and drawn out, but it follows a fairly simple plan here. So I'm going to grab the original rules. I'm going to get rid of Dave's rules, and I'm going to go with the original Sumo Rules. I'm going to open here, and we're going to show what's actually happened. So the first thing that happens is the robot starts. So the robot starts here with this block here at the top, and immediately the robot is asked to wait until the line sensor says it's all black underneath of it. And after that, it's supposed to wait 2 seconds, and you've all seen that. If you just watch those 3 matches, you've seen there's this 2-second pause, and then it starts going, and it will follow everything inside this loop right here. See that repeat until? So it will repeat everything until it detects no line, no black line under it. So as long as there's no line under it, it will keep doing all of these things, and it will ask these questions. If the line sensor is black, go forward at 50% power. Is all black, so it's moving straight forward. If it detects some white under the right or the left side right here, one of these if blocks right here, one of these two if blocks right here, it sees a little bit of white on either the right or left side. It changes the power to the tracks so that it shifts back. And I physically saw that. What I saw myself was as the robots were moving straight, they would veer a little bit off the black line and come right back. And that is part of the dynamic into why they were getting locked, because if you have these two robots right here and they're coming at each other and they have no option to veer right or left, they can't catch each other here and fight it out. They can't do anything here because they're going to get stuck on their lights like that, or on their eyes. They're going to get stuck on their eyes like that. So that's happening. I'm standing over the match so I can see it happening. I see it in real time. I think that's super cool because our robots are following the rules, first of all. But I also think that's super cool because it gives us some insight into what might be going on and might be going wrong, or how to create more code to get out of this. And as I come back here, the last question is, if it detects an object within 10 centimeters, it goes into this new loop where you can add your own code to the moves here. And that is where we see the robots doing different things, whether they're speeding up, whether they're trying to shift right or left a little bit. And, excuse me, I'm not so sure that my lift and shift robot was doing what I wanted it to do. So I'm going to open up my code, which I'm not changing, but I'm just going to show. I'm going to talk through it because I don't think it was following this code. So I asked it to move back, to move backward, if he feels like he's going off the sensors for just a half a second. Otherwise, I want him to go forward all the way. And I think that is happening, but he's not detecting all black. He's detecting no black. Or I'm sorry, I will say this. I will say that it seems like the sensor is tripping, and the actual robot structure is tripping the sensor, so that when it lifts up, it can't see white under it because it's seeing the blue and the black from the other robot. So it's possible that there's a flaw in this block of rules for the robot, because the robot doesn't know that he's up off the line, because he can't see the difference between the black line and the blue part of the robot. And I'm going to come back and show that in like real space here, because it's easier if I just back up and show this. So here is this line sensor right here, and it detects dark and light, not specifically white and black. So the funny part is, when these robots are locking like this, that sensor is now picking up the blue from the robot momentarily, and it's not completely light, it's not completely dark, but it's dark enough to reflect a signal that says it hasn't left the line yet, basically. So there's small intricacies about how the sensors are only going to tell you what they know, and you're not going to be able to. It's not really the robot not listening to us; it's the robot not listening to the right responses, basically. So, and I've encountered this before with other things. In fact, Dave and I were talking about this earlier. The fact that different tapes. In fact, I have a different roll of tape right here. There's this. This is black hockey tape, and this is black electrical tape, and you can see the shine on one, and there's no shine on the other. But interestingly enough, this is a black line that the robot can follow. This is a black line that the robot cannot follow. Because this doesn't reflect light back up in the same way that this one does. The little line sensor can't see this black. So sometimes I do some things and play with the robots, and what ends up happening is I kind of like play tricks on the robot, because the robot's only doing what he's told, and the robot's only seeing what he can see. It's kind of like a dog whistle. We can't hear a dog whistle, but dogs can, because their ear sensors are different than ours, and they can pick up different range of sound. And this robot is basically the same way. His light sensor is designed so that he can only detect certain conditions, or certain states in certain conditions. He can only detect certain kinds of black, not all kinds of black. It's not like we can see. Our eyes are much better, they're built better than an infrared LED and a photo detector, which is basically what that sensor is. That sensor is a little maybe I can get close enough for you. You can see there are two sensors right there. In fact, if I turn it on for a second, you can see that they show up. Those little lights show up here on the screen. I can't see them because they're infrared. The camera will detect them because the camera can detect a wider range of light than my eyes can. But those little lights right there shine down and shine back up into the bottom half of this little block right there. And you can kind of see it right there. But it's a photoresistor type sensor. So that glowing little pinkish light shines down and up, and it's invisible to us, but the robot gets to see it. And there's complicated physics behind it. The light that shines out that I just showed you, this little light right here, that light right there. See it flash again. I'm going to flash it a couple times just so you can see it right there. You can actually, on this close, you can see the two different sensors, the light and the sensor. But the light that's coming out of that is a specific wavelength. It's and I don't know what the wavelength is off the top of my head, but I know it's a specific wavelength of light, an infrared light specifically, and it will, because it has different properties when it's in different wavelengths. It doesn't always reflect evenly off the same structures as daylight does. So there's easier ways to fool the little black dot. The little black dot right here is the one that looks for that light reflecting back, and there's easier ways to trick that light, to trick that sensor. One of those ways is using these two different tapes. You can see that once again, just right there. Just my nerdy little science fact. I'll stop because it's kind of cool to me, but that's about it.
So what makes you work on the project, and that's how you understand it.
Yeah. Yeah. So I have in the past, in some of these in-person events, used this tape and discovered it was a huge fail. And nowadays, the mat that's right up there is electrical tape and corrugated plastic. It's called. I call it plastic cardboard, but it's corrugated plastic is the arena is set up, and I've got it fastened together in various ways, and very small 4-inch black line. It's actually about 3 inches, but yeah, cool. Did I take up too much time for you, Dave?
No.
Cool. I'm gonna go back to our chat because I can't see our chat, so just interrupt me.
Yeah, no, you're on a roll. I'm gonna let you go,
Fair,
man.
fair, fair. Yeah, and Dave, I'm gonna download this one and see if it automatically changes the name for me.
I changed the name so it does.
Oh,
So it's easier to find as well.
oh yeah, okay, cool. I see it. Excellent. Yeah, so Dave has, as part of our design team, Dave has things around him as well. We have some smaller robots that we do this with. We don't always do this with the Ranger tank, and Dave's actually been behind the scenes doing some other stuff. I'll chat a little bit more about that. But now that I have Dave's code, we're gonna hop right back into uploading Dave's code again. So I'm back in the browser. I'm opening from my computer. And Dave has so kindly added Dave in caps to his new file. So it was super easy to find. And this is Dave's new code. And just a quick skim, it's got all the same parts. It's got the lights on at the end that we know we need to see. It's got the, it's looking for this. It's got looking for line sensors. Oh, there's the missing part at the top. I don't care about that. It was the
I removed that because I wanted to see something.
Oh, yeah, do it. That's even cooler.
Yeah, I removed it because I wanted to see what the difference it makes.
Yeah. Okay. Note it then, and when we have workshops later, we can figure out what happens, what doesn't happen, and we can have those chats in the other Zooms.
Right.
I dig it. So I'm going to set aside the lift and shift robot. I've got out the 3D fuel robot that Dave's driving today. I'm going to add or connect the USB right here. It's lit up. I'm going to turn it on also so that it's going, and we're going to switch to this view. I'm going to connect to the 3D fuel robot. Here we go. And I'm going to upload. I'm uploading Dave's code right now. And you can see some commands here. In the next break, I will pick through some of those commands and see what happens. So Dave's robot is already on the move. He's fired up. The 3D fuel robot is ready. I'm going to disconnect him now. And we're going to head to the mat. So as we get back over to the mat, I'm on the left side of this mat, my workstation, so it's easier for me to drop down the lift and shift robot first. When I set them down, I put them both on the ends of the line. Like I said, the line is about 3 inches thick. I wasn't very exact with that today. There may be a time when we do. And I'm gonna get them going right now. We're gonna do best 2 out of 3. And go. Have at it. Whoa. He was fired up. And they're shifted. They're off to the side a bit. They're not hitting directly on each other. But this tread right here is now the one catching the eyes on the lift and on the 3D fuel robot. So we're gonna give them another second, see if they can get out of this before I give them a countdown. But it does look like they're stalled. I see no. Oh, nope. Is he giving up? Is he giving up? Nope. And just some commentary from the upper view. Both of these robots seem to think that they have the black line under them. So I'm going to try something while they're going, because I see a very dark shadow, and I'm realizing our arena might need some lights. So what I'm going to do right now, while they're going, is I'm going to turn my phone's flashlight on right over this and see if that changes the light sensors in any way, and it does not. So there's a bit of detection that the light is not getting. or the light is not reflecting back up. So the little light is reflecting down and it's not coming back up. And I will explain a little bit more of that in the next break, but I think I've now solved a solution to this. We're going to count down to 5 though. 5, 4, 3, 2, 1. Call it a draw. Cool. Nope. You go back. You go back, sir. Okay. Are we ready? Ready to go? Right now. Go. Oop, oop, oop. What? They're just stopped. They're just stopped. And it looks like he just doesn't have enough torque to even go up any higher. He's not stuck. Nope, he's not stuck. He just doesn't have enough torque to go any higher. I wonder if his batteries are dying.
Oh boy. Didn't make sure you had good batteries.
Yeah, I could probably... I don't know if he's struggling or not, because... I want to say that's what it looks like. The lift and shift robot might actually be struggling today because his batteries are low. He's just not able to climb the treads anymore, or his batteries are getting low. Maybe they're slowing down because he's not climbing all the way back up in these matches. But we're going to call this one a draw also. And we're going to put him back. And we're going to go for last round. Last match in round 2. Ready? Have at it. Dave, your robot seems to be stopping now.
Yeah, I'm trying to figure that out.
Yeah, the 3D fuel robot it's moving, then pausing. And he's moving again. He's see him taking a step forward?
Yep.
And then he stops. Very interesting. But I think the lift and shift robot is definitely dying. Battery-wise. Yeah. They are just not very much fun right now. So, we're going to call it a draw for round 2 of these matches. And I'm going to give you, Dave, the option to do some code while I explain a couple things. And I'm going to come back with some batteries and talk through what I saw. While I swap out some batteries. So there were 2 things happening. Hey there. So there were 2 things happening today. One is a physical issue that with the batteries, not enough power to push each other off the lines, and we can solve that right now. I'm going to talk through some of this while I'm swapping batteries in both robots quickly. And batteries are kind of a challenge because they're under this box. So they're under here, they're under there, right there. So I have to take this part off to get to the batteries, and it becomes a bit of a challenge. But we're going to swap those very quickly for both of these while Dave's updating some code. And I'm going to explain another factor that's happening for us. And this is a bigger picture factor, which involves those line sensors. And what you may have seen, and I will show you again very quickly on the other robot, on the 3D fuel robot here. You see it. See I'm flashing the little sensors? Those sensors they're using the power from the batteries to shine a light, like a flashlight. And as they're doing this, the light is reflecting back up. But those little lights, those little LEDs, are only so powerful. So imagine you have like a flashlight on your keychain, right? And it's not very bright. You can't use it for much other than, finding your keys or finding the hole to... Don't mind me, I'm just dropping batteries. Finding, like the keyhole in the door. But if you have like the headlights on your car, that's big enough to see a deer, from hundreds of feet away. So I'm bringing this up because those two different headlights have different power settings, and they reflect back the same type of power. So what I'm saying is that the light sensor that we're using on this robot can only reflect a surface so many centimeters away. And I'm gonna show you an example in just a second as I'm opening batteries. Believe it or not, the hard part was not opening the batteries. The hard part is getting them in this battery box. But the challenge for us is that we're asking the sensor, the light sensor, to tell us a condition that it can't accurately tell from a certain distance, basically. The light sensor is only good from so far away. I see a file there.
Yep, whenever you're ready.
Cool. So I'm almost ready. I'm almost done swapping batteries in the lift and shift tank. That just happened. So I'm going to attach the screws right here. Make this go fast. And I'm going to quickly swap the batteries in the 3D fuel robot also. Because I don't want one of them to blast the other one out of the line if that happens to be the case. So I'm going to set aside the lift and shift robot, but I'm going to quickly explain. So this sensor right here, this light sensor, as I flash the lights, is only this high off the ground from the tank. So this light is reflecting down and up, and it can travel a certain distance in doing that. So we're asking it to, when the robot lifts up like this, all of a sudden the light is no longer A, at the right angle, B, at the right distance. So between those two, it is not reflecting that light back. So one solution to this challenge that I will share right now is to change the light sensor code. We're asking it if it sees light or black under it, light or dark under it, when we should be switching those so that we should basically be switching those two commands so that it's not getting confused, because it thinks it's still on the line, it thinks it's still dark because it's not seeing the reflection, is basically the short version of the problem. It can't see the reflection of its own light, so it always thinks it's on a dark surface. So we should be telling it to look for a light surface and using that as the criteria for moving off the line. That swap may give us a better result in future matches. And I will mention something else while I'm going on. It might also be helpful to add a block of code, or add a code block that questions whether or not there's still an object in front of it. And the reason I say that is we have these robots putting on their judo moves in the middle of right after they confirm that there's a robot in front of it. So there's this block of code, and if we look at it right there, it says ultrasonic sensor port distance 10. I'm going to zoom in on it super quick while I'm in between batteries. So this block of code right here could be a problem because it only happens once. It's not continuously checking. And if we were smart in our judo moves, we'd want to know if our position had shifted to the point where we could no longer see another robot in front of us. And that is what happens because you in some of the previous matches you see the eyes aren't lined up anymore because they're not looking at each other. And that may give one of our robots an advantage of saying, oh, look, I don't see him anymore. I don't know what he's done to blind me, but I need to do something else to get back to where I think I need to be. But these are some of the things that I am very interested in picking apart as a robot coder in our next Zoom session next week, where I will try to pick apart some of the flow of this and say, hey, does this work? Hey, does that work? Obviously not. And I've just swapped the batteries in the 3D Fuel robot. Choo-woo! And hopefully these batteries work better because they've been over in the cold. But Dave has some code ready. I'm going to come over to our Zoom chat, grab Dave 2 code, and open from my computer. So this will be big round 3. We're going to quickly fly through connecting the robot. The 3D Fuel robot is connected, and you can hear him revving up now. He's fired up. Now I've just connected him. We're uploading the code. Here we go. I didn't get a chance, but you can see the word Arduino in there. These are built on a simple Arduino microcontroller. It's a custom controller from MakeBlock, but these are simple codes that can be used off of the MakeBlock platform if you know Arduino C or any of these other programs. So we've got our robots set up. I'm just going to double check. That the lift and shift robot's working. Cool. And back to the arena. You set these big guys down. Right on their mat. And 1 second while I grab some accessories. Are we ready? Last match. Let's get it on. Go. Uh-oh. Oh, they're struggling. They're struggling. But they're still going. They're still going at it. They're still moving. How is he not off the line? He is off the line. I see him off the line. Cheater.
Who's that? Which one's off? I got a game.
Hold on. The lift and shift robot is definitely off the line.
Oh, yeah, now I can see it.
I see both lights, both blue lights right there are on, and he is not flagging it down. He is definitely the loser. Definitely the loser there.
Wow.
What a cheater. So there's something with the code there, but we're gonna try this again. That was much better. New batteries livened the place up, right?
Yeah.
All right, so we'll go again. Go. And they're locked. Oh! I don't even know what to call it.
That was definitely a lift and shift. Wow, that was a lift and shift win on that one. But who lost the battery?
Lift and shift lost the battery. Wait. Yeah. Nope. They both lost the battery.
Oh.
No. The 3D Fuel lost the battery. Yeah. 3D Fuel actually lost the battery. Let's see if I can get it in there without the struggle. Right here on the mat. Sometimes I actually need tools to do this. Nah, let me grab some tools. That was lively though.
Yeah, that was definitely not it.
Here we go. So let's straighten out the 3D Fuel robot. We're gonna try to get those batteries back in there. Actually, we'll do this right live on camera. Last update. Our little pit stop. Dun, dun, dun. And batteries are almost in. One more. Sometimes the batteries are loose, but they don't actually fly out. No! Okay. I'm trying. And I'm failing. There we go. There's a very tight fit in these battery boxes as more batteries are popping out. No, sir. That is not what I asked. All right, we may have to call it a draw for overall for the day. The 3D Fuel robot here won early, and it looks like the lift and shift robot came back after a battery update. But now my lack of dexterity is proving not to be an entertaining endeavor. So, let's just bring these boys back to the table. And call it a successful day. Wow, okay, so we kind of went over a little bit over my target time, but I'm not stressed about that too much. Dave, what did you see on that last one that you wanted to point out? Anything?
I'm not sure really, because there's a major delay between watching Twitch and hearing everything that you're doing.
Yeah.
One of the things that I did notice was that after the battery change, both robots wanted to go. I think there was a coding in there somewhere that kept delaying what I was inevitably trying to get done. And I did like the lock up there on that last one. As we were going for it, they both, you know, like you said, the lift and shift was pushed off the line, and it didn't blow its horn like it's supposed to. So now that's something that we got to work at and figure out. I think that it went really well, especially after the fresh batteries.
Yeah, I think that's a valid point. And when I do these in person, even with the smaller robots, they're frequent battery changes. And right now, I actually have the 3D Fuel robot powered up again. We could do a quick one last run with full power and see what happens. But yeah, I'm with you. It seemed like the lift and shift robot here was off the line, and I saw both blue lights on the sensor that indicate that he was off, but he just was not showing the last set of commands from the blocks. So I think there may have been a flaw in the upload. I'm not quite sure. But the code was there, and we've tested this stuff previously, actually earlier this week. So we know that the code was working and it was happening. And I didn't make any changes to the sumo battle. Or the sumo instructions. I just added the blocks for me in the middle.
Right.
So I find that odd. And if we were going to do this all day, I would actually stop and go through all the code. But that's what we've set up, kind of like workshops outside of Twitch, where we can be nerdy and boring and solve problems there. This was supposed to be like the battle part, and
change your code on the fly and
yes
adjust. One thing that I've got to remember to keep doing is renaming each update, so that way I can go back and look at each individual ones.
I got you. Yes, I dig it.
Because I actually did miss one of them.
Okay.
Unfortunately, I can't go back into the chat and pull that one back.
I have them. I can send them to you when we do the workshops, or I can drop them in Slack or something.
Yeah, we can connect on that part.
Yep.
After
Yep.
the live here. But
Yeah, definitely.
I like this. It's on the fly coding, and we're doing what we want to do. We just gotta work out some technical issues, but I think we're doing all right otherwise.
Cool. Yes. These batteries are so hard to get into this Ranger. I really wanted to do the next one last full speed showdown. There we go. Yep. Okay. I'm putting the 2 screws in right now.
Alright, well, we can go for another one then.
We can go for one more.
See what we get. Yeah, so it's 1-1 on this round 3.
Yes. And I'm now not smart. Actually, he can go with 1 screw. It's not going to hurt him. Let's do it. One robot down. 2 robots down. Ready? Let's go. Have at it. Oh. Oh, and they're struggling. But they're not giving up. It's still a fight. It's still a fight. It's still a fight. What are they? There he is.
Oh, yeah. Oh,
He's-
who got it? Who got it?
3D Fuel's the winner.
Oh, sweet. I like that. The lift and shift actually backed up and said, all right.
He gave up. He said, I'm done. I lose. That happened. It worked. It worked just like it was supposed to.
Yes, that is awesome.
I dig it. I'm so glad we waited. Let's try it one more time.
Sure.
Ready? Go. Have at it. Oh! 2 batteries down. I think that might be a draw.
Yeah, I'm gonna call that one a draw.
That was hysterical. That was awesome. And on that note, we're just gonna leave them sit there. I'm just gonna come back to my workstation here. That was incredible.
Yeah.
That was worth it.
The end result of what the lift and shift robot did there on that second match part there. We'll have to get these words right. So we know what yeah, so I'm excited to see what else we can do.
I'm with you. I'm
excited.
I'm right there with you. This was fun. That was a blast. The last little bit, the batteries made a big difference, and on top of that, we got to see the code. We got to see the code work. We got to see the robots follow the rules, follow the instructions. It was exciting and fun, and the 40 minutes of lead up to it certainly didn't disappoint for sure. I dig it, and I think now is when I should probably take 2 minutes quickly to say thank you, and this was super cool. But behind the scenes, we've been working on this kind of stuff for a while now, and it's fun to like do it and share it. And it just like you said, this is a cool game to play. This is cool, just like any other game you're going to play on Twitch, except we're doing it with live robots right here. I've changed my apartment for the day. I got rid of the fancy beanbag couch to build this, like a 5-foot arena over there in the corner. And these are real robots. We're doing this real time, just like any other game that you might want to play. And it's just us, a couple of veterans, getting together from not anywhere near each other. I mean, you're literally hundreds of miles away. And
probably about 6-7 hours, depending on the traffic.
Exactly. And we can connect and do this live in person, and it's not too challenging for us to transfer the code back and forth. And being on the design team with the foundation, you've also done more behind the scenes to help develop the code, help develop the rules. And we've been chatting about how we can change this up and add like do your own fighter with different robots and different events and challenges, not just the sumo battle. So I'm excited to see where we as a group take this, not just me or the foundation in general. It's meant to give veterans a way to play with us being from a distance, or over December around the holidays, I had my kids join me from the Carolinas, and I got to sumo battle my middle son for about 45 minutes or so. So this is the kind of thing that I would love to see bigger and outside my apartment, even once we get back to real events and less crazy viruses. But definitely a thank you, because it's the highlight of my weekend for sure. And I should also thank there's 2 little tags at the bottom, Clever RX and Amazon Smile. Do a job of supporting us. I will say that. But we have some other sponsors. Masterclass, which is not on that little tag and in that list, gives us access to masterclass.com. They've done it for the last couple of years now for our veteran community, the small group of veterans that we can reach. It's a free year of Masterclass to learn. And that happened when the pandemic started, because so many veterans were at home and looking for ways to learn and connect with other people. So that's available, and I am always greatly appreciative of Masterclass, and Jay, our board member, who makes that possible. So thanks, Jay. And we have other sponsors that I'm just drawing blanks right now, but I will add them to the list soon and share more. That's it. That's all I got. It's 2:15. I drug this out a bit, and it was worth it to me. It was a lot of fun. I dig that. We'll go back to the drawing board and come up with something new for next month, though. Maybe change the rules a bit. All right. I'm mashing the end string.